Hello, my name is Masatsugu John Sugie, and I am presenting on predictive analytics in software design. End users of software will occasionally not know exactly what features and functions they need from their software. Predictive analytics may have the capability to help software engineers find out what those requests will be before they creep into and ruin already developed software, saving time, money, and inevitable heartache. If you want to, you can pause the video and look at the picture on the right. I like this infographic because it really shows you how predictive analytics has been used for many years by all the great technology companies of the past and present. Its value goes from back office automation to real-time optimization and everything in between. Predictive analytics is a sort of speculative form of data modeling. Predictive analytics uses many techniques like data mining, the practice of examining large pre-existing databases in order to generate new information, data modeling, an abstract model that organizes elements of data and standardizes how they relate to one another and the properties of the real-world entities, statistics, a branch of mathematics dealing with data collection, organization, analysis, interpretation, and presentation, machine learning, an application of artificial intelligence, AI, that provides systems the ability to automatically learn and improve from experience without being explicitly programmed, and artificial intelligence, intelligence demonstrated by machines. All of these analyze current data to make predictions about the future state of that data. Now, I have a question for you, listener. How is predictive analytics used today? Please pause the video and try and come up with some ways predictive analytics and software has already affected your life, starting now. If you said in countless ways, then you are correct. Take, for example, law enforcement. If anybody watching this has had their identity stolen, then I am sorry. For the rest of us, law enforcement has kept us safe from those criminal activities. By tracking behavior, law enforcement can detect cyber fraud, zero-day vulnerabilities. That is an unknown software vulnerability. The first time you learn about such a vulnerability is called day zero. Before then, 0 days. And advanced persistent threats, which is a hacker in a system for an extended period of time. Another example is marketing. As a former marketing manager, I would use marketing tools like Prism Marketing to gather vast quantities of data to better understand a consumer base. Think of how your local grocery store will give you coupons for milk on Tuesday because they know you always buy cereal on Monday. Business operations use predictive analytics to forecast inventory shortcomings or overstock. Walmart uses this brilliantly to save on logistics to give you the lowest possible prices. Finally, we come to risk management. Think of a bank leveraging the credit data of someone applying for a loan. But risk is also where predictive analytics comes into play regarding software development. Software developers can use predictive analytics to test data for possible risk indicators. Another great thing about predictive analytics is the ability to make recommendations to upper management on how to tighten controls or change processes to reduce the likelihood of non-compliance. If all your data shows that users will not use a particular subset of controls, then why write them in your code? Save time, money, and needless testing. Now, let me name drop some famous companies that are actively using predictive analytics in their software. Netflix, which is located in over 190 countries, is incredibly data-driven. Their software system has to search through millions of bits of data to predict what users will watch. They also use this in developing their ever-evolving software to try to find hidden algorithms that can parse through the data. Facebook has found that through their data, romantic relationships that last more than 3 months on their social network are likely to survive for years. It is even sometimes possible for them to predict who will be in a relationship with each other next. I can't imagine what their software looked like to be able to predict that. Amazon keeps track of customers' past purchases and items customers have rated and liked, then compares similar purchases by other customers. and then in real time recommends other products before you've even purchased the contents of your virtual shopping cart. Boston Medical, the largest hospital in New England with over 514 beds, and other similar hospitals, have to always update their software algorithms for changing demand patterns, so hopefully wait times are lessened. Finally, Oracle, home to all our Java docs. As the second largest software company in the world, they use an internal automated form of predictive data mining and use predictive lead generation software like LeadSpace and the IKO system. LeadSpace pretty much compares people's online presence to a vendor's unique ideal buyer profiles. IKO is pretty much a spam email algorithm. You can see that almost every big name company is using predictive analytics in some form or another. So the big question, how exactly does this help specifically with creating software? Software developers collect massive amounts of data related to testing, running a build, and other tasks. This data already dictates the short and long-term success of a project. What predictive analytics does is find patterns hidden in the datasets. To develop the necessary algorithms, software developers use big data. More specifically, the 3 V's of big data: volume, the large amounts of data; variety, the test results in log files; and velocity, all the data being processed at a high speed. Going through all this massive amount of data, software developers can identify patterns and forecast future problems that an end user might face. If predictive analytics is part of the designing steps, then it may be able to help users find out what features their systems will need. An example of how to use predictive analytics is using a weighted score to find patterns in historical and transactional data that can be used to identify risks and opportunities for future applications. The predictive analytics models capture relationships among many factors so that it can assess risks with a particular set of conditions by assigning a weighted score. In this particular example, option 3 is obviously the higher scoring variable. If predictive analytics is successfully applied, this can effectively interpret big data. An example of how to use predictive analytics is by looking at triadic closures. Triadic closures are the properties among 3 nodes, for example nodes A, B, and E, such that if a strong tie is exhibited between nodes A, E, and BE, there is either a strong or weak tie between nodes A and B. In the graphic I made, AB is most likely to be a weak connection. Within identity and access management, creating and analyzing software triadic closures with structural balance helps you identify users who have, or need to have, access to structurally similar assets or other applications. This helps you set more accurate inheritance rules. This presentation is about software analytics, so let's get into the weeds a bit now and describe all 7 predictive analytics and software design procedures. The predictive analytics process starts with defining the project outcomes. You must define the deliverables, the scoping of the effort, the business objectives, and identify the data sets which are going to be used. The next 2 steps are data collection and data analysis. Data mining is conducted from multiple sources for analysis. This provides a complete view of the customer interactions. The goal is to discover the patterns, the trends, and the behaviors in large data sets. Then the data is inspected, cleaned, transformed, and modeled with the objective of discovering useful information and arriving at conclusions. When you clean data, you correct the outliers and other incorrect and unwanted information. Statistical analysis enables us to validate the assumptions, make hypotheses, and test those using standard statistical models. This is done by summarizing the data population and describing what was observed graphically or numerically. Predictive modeling provides the ability to automatically create accurate models about the future use of programs. The 3 modeling categories are predictive, analyzing past performance; descriptive, quantify the relationship in data into groups; and decision models, describe the relationship between all the elements to predict the result of decisions. Then you deploy the model. When you deploy the software, you release it to the customer or end user for use. Moreover, deployment can also mean deploying the analytics to engineers to use in developing their software designs. This is followed up by monitoring the model with analytical algorithms and a scoring system. The model is applied to new data that doesn't have a dependent variable. This ensures the impact of the model is handling the data correctly. performance is not reducing over time, and it is providing the expected results. Last but not least is Gartner's Hype Cycle of 2018. For those unfamiliar with Gartner, and according to Wikipedia, Gartner Incorporated is a global research and advisory firm that provides insights, advice, and tools for business leaders across the world. Gartner's Hype Cycle provides a graphical and conceptual presentation of the maturity of emerging technologies through 5 phases. If a technology is located in the innovation trigger, it is a potential breakthrough technology. If it is located on the peak of inflated expectations, early publicity has produced a number of success stories. If a technology is located on the trough of disillusionment, interest has waned as experiments and implementations failed to deliver. Only the strong survive the trough. If a technology can get past the trough and into the slope of enlightenment, then more instances of how the technology can benefit enterprises are present. Last is the plateau of productivity, where the technology has become adopted by the mainstream and there is a broad market applicability and relevance. Continued growth is expected. Of course, this hype cycle is not perfect and occasionally stumbles, but if you look at the red arrow on the graph, predictive analytics is just entering the trough of disillusionment and may take 2 to 5 years to reach the plateau. Now I can hear you say, wait a darn minute, if predictive analytics is in the trough of disillusionment, that means it's going to fail. This graph is not scientific, more speculative, and we should not get the wrong idea about how to use this technology. Furthermore, a new type of analytics has been created called augmented analytics. This quote is from Gartner's Top 10 Strategic Technology Trends for 2019. I won't read the whole quote, but you can pause the video if you'd like to read it. To sum it up, you can see that even though they previously spoke about how predictive analytics is being used ineffectively, a more intuitive form of analytics is beginning to emerge. This form will be more available and easier to use for ordinary people, rather than just for analysts and data scientists. It is important that we learn about analytics as soon as possible to stay ahead of the curve, because in the future, the words machine learning and AI will be more than just buzzwords. They will be part of our everyday lexicon.